so this is where we ended the last. We were talking about by this theorem here, we could find a position vector. Remember, the position vector starts at the origin, then goes out a certain magnitude, direction, and no matter where it is, I can actually pick this up and move it to become a position vector. So let's see how to do that. So get my ink color going here. It says find the position vector of, I have a vector v. Here, if P1 is -1, 2, and P2 is 4, 6. So if I do this with Keith on my desk and trying to take my pencil, then all I'm going to do is I'm going to do the x2 minus x1 and then y2 minus y1. And so in this case, that would be 4 minus -1. So notice x1, y1, x2, y2. And then 6 minus 2, which would give me 5, 4, which would be my position vector. All right, if I want to see what this looks like, then I can see here, notice -1, 2, that point, 4, 6, this point. What I just found, that 5, 4, puts it in as a position vector starting at the origin, and then that's the actual point that it would end at. All right, so two vectors are equal if and only if they're components. Remember last lecture I said components, write that down. So only if their components are equal. So in other words, the A1, B1 or X1, Y1 and A2, B2. And so they are only equal if the components are equal as well. All right, so then I have the unit vector. So remember we said last time the unit vector is 1. So let I denote the unit vector, and let's put it here on the positive x-axis. And then let J denote the unit vector on the positive y-axis. Then as you can see, based off of this, I have my unit vector I, 1, 0, my unit vector J, J, 0. And so it says that any vector can be written using unit vectors, and that's what we're going to do, is use unit vectors, where A is the horizontal component. So this is typically where you have something moving horizontally and then also moving vertically, like an airplane, right? And so I can write it as my component vectors here. So in other words, take my components and write them as a unit vector. So for example, if I have this vector 5, 4, then 5i plus 4j. So remember, these are my unit vectors, my horizontal and my vertical, where 5 is the horizontal component and 4 is the vertical component. All right, so if vector v has an initial point 3, 2 and a terminal point 5, 6, I want to write the vector in the form of my position vector. So in other words, with the units. So let's find the position vector. Let's get my pencil going here. Yeah, we can use that color. Let's try this color. So in other words, I'm going to find, and I mentioned that sometimes I do an arrow above it, just states that that's a vector. And so I would do this with the x's, and then this is my horizontal, and then 6 minus 2, which is my vertical. So this gives me, of course, 2i plus 4j, and thus I have my position vector with my components 2, 4. All right, so next, as we can see here, once again, more properties is based off of, if I have the scalar, I can do the same thing with the scalar. with my unit vectors. Okay, so the components, in other words, the horizontal piece and the vertical piece, I can do the same thing where I can just take these scalars and add them. I can subtract them. I can pull the scalar out. So in other words, out front, and then just multiply by a particular value. And then once again, the magnitude, same thing, is squaring the two values. So in words, to add two vectors, add the components. To subtract, subtract the components. So for example, if I look at this picture and it's V plus W, it's actually composed. So notice here that we're looking at the unit vectors. Okay, so this is my horizontal. So I've gone the horizontal distance, and this piece is my vertical distance. Going the vertical distance gets me to that point. Same thing with a scalar here, scaling once again. So if I have a scalar and I start out with this position vector and I scale it in a horizontal distance and a vertical distance, then I end up with my scalar times my vector. My magnitude, still the same definition, but notice it's taking my horizontal distance, squaring it, and then plus vertical distance and squaring it. Okay, so it's once again the distance formula. All right, so let's look at some examples. So if I have these two vectors, and again, let's go green. And let's say I want to find vector V plus vector W. Okay, once again, we can see that this is the horizontal unit vector and then the vertical unit vector. And so all I do with these then is, of course, I would write this vector plus, oops, that's an I, this vector. And then, as you can imagine, I would, by the properties, I can take out my values. And so notice I'm going to put the i's together. Okay, so I grab that one and this one. And then the j's together. And so I get 5i minus that vector j. All right, if I want to find, and I want to subtract these, so subtracting the two vectors, well then I just do the same thing, but I'm just subtracting. So 2 minus 3, I'm just looking straight up above. And then, oops, sorry, that should be minus, because I'm subtracting the 3 minus 4j. And so, of course, this is going to give me a negative I and a negative, a positive j. All right, let's do some other things. Let's say I want to find, I have a scalar 3 times my vector v. So as you can guess, I'm just taking and I'm multiplying 3 times my components. Okay, so I get 6, ooh, don't know what happened there, I plus 9j. If I want to find 2v minus 3w, you can kind of just look at it, right? So in other words, 2v would be 4i plus 6j, so just multiplying by 2. And then minus, I'm going to put this in parentheses, so now I'm going to multiply w by 3, so that's going to be 9i minus 12j, And then finally putting these together. So I'm going to have 4 minus 9, so negative 5i. And then 6 minus a minus 12, so negative and a negative positive, 18j. All right, let's do one more where we do the magnitude. So if you're asked to find the magnitude of vector v, again, all you're doing is square rooting both components squared. So that becomes 4 plus 9, which becomes the square root of 13. So a lot of just algebraic techniques with the vectors. And we'll keep on going the next lecture.